Alright, integrated 1, what we're going to try to do here today is continue with the work that we did on Tuesday, which was proving that a quadrilateral was a parallelogram. Today our focus is going to be looking at, is it a rectangle as far as our notes go, but I'll show you some other places where this rectangle idea could come into play. Alright, so this is section 25.2, which is on perpendicular lines. Okay, but I'm going to review quite a bit here, and that's the way I try to teach this chapter, is continue to review the information from the days prior so that hopefully you have the best chance possible. Alright, so let's review real quick. How are we going to prove that something is a parallelogram? If you did the work on Tuesday, you know that there's really three main ways. Okay, opposite, sides, parallel, and that's with slopes. So we're going to look at the slopes and see if the slopes are the same. The second thing is going to be that opposite sides are congruent. Okay, and the way we'll do that is with distance formula. And the third way is going to be the diagonals bisect each other. So the diagonals are going to bisect each other, and the way that we'll figure that out is with the midpoint formula. Okay, now, what we're going to focus on today is rectangles. Okay, now how will I know that a rectangle is a rectangle? Okay, well there's two main properties for a rectangle. That would be that there are 4 right angles and the diagonals are congruent. Okay, so how are we going to do that? How are you going to figure out that a rectangle has 4 right angles? Well, to have a right angle, you have perpendicular lines. Okay, so how can I show that the sides are perpendicular? Well, what does it mean to be perpendicular in terms of the slopes? That's what you want to think of. Slopes are opposite reciprocals. Okay, so the slopes are opposite reciprocals. Now, lastly, how are we going to figure out that the diagonals are congruent? Again, we'll do that with distance formula. Okay, so distance formula there for that one. Okay? All right, so let's jump right into it. Let's do an example here. See if we can figure out what's going on here, and then I got a few closing statements to make that'll help you with maybe another shape if that were to come up. Alright, so here are our points. I'll write them down first for our example. A is going to be -3, -1. That B is 3, 2. That C is 4, 0. And that D is -2, -3. Okay, those are my 4 points. Alright, we need to go ahead and draw a 4-quadrant graph in first. Okay, so let's go ahead and do that. I don't have my ruler sitting right here, but that's okay. I can use this sheet of paper. Make some nice straight lines. Okay. Alright, and numbers are pretty small here, so going to 5 by 1s is going to be fine. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we got point A, -3, -1. And again, it's very important that you label these next to it so that you know what point you have, because you are going to be using those points, especially when you're doing distance formula. Okay, so we got -3, -1. We got 3, 2. So over to 3 up to 2, that's point B. 3, 2. C is 4, 0. 1, 2, 3, 4, 0 right there. There's point C. And point D is -2, -3. There's point D, -2, -3. Alright? Okay, so let's go ahead and connect those dots and see what we're looking at. Okay, so you're connecting, I'm hoping. I'm connecting to. And again, knowing the properties from the last chapter, that is the key. And I know for some of you guys, you didn't watch the videos, and so now hopefully you're trying to catch up and get those in. We just didn't have enough views in the last sets of videos to know that all of you were watching them. So now, we've got our quadrilateral. First thing you want to look at, is it a parallelogram? Okay, to be a rectangle, you got to be a parallelogram first. That means that this side is parallel to that side. So this is just kind of a quick check. Is the rise over run from here to here the same as from there to there? We would go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. And from this point, go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. If it's rise 3, run 6, those two sides are parallel. This slope here, down 2 over 1, down 2, 1, 2 over 1. Okay, so it is a parallelogram. All right, so now let's check and see if this is a rectangle based on having 4 right angles. So what you really want to do is you do want to find those slopes and then see if they are opposite reciprocals. So again, the slope of this side was to go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. Rise 3, run 6. The slope of this side is 3, 6, which reduces to 1/2. That's the slope of that side. We decided that this side was parallel, so its slope is also 1/2. Okay, we don't need to recount it. We just did that. Okay, now for this side, go down 2 over 1. So this slope here is negative 2 over 1. So negative 2 for your slope there. This side here, down 2 over 1, the slope is also negative 2 over 1. So, are these sides perpendicular? Are they right angles? Well, are they opposite? One's negative, one's positive. Are they reciprocals? Yeah, they're opposite reciprocals for the slopes. So, are these two sides perpendicular? Yeah. What about these two sides? Are they perpendicular? Opposite reciprocals again. So far, we have the sides being perpendicular. That means that we have 4 right angles. Again, this is the way you show that you have a rectangle. Again, we have 4 right angles. But we also need the diagonals to be congruent. Okay? So what we need to do is we need to find the distance for BD, and then we also need to find the distance for AC. Because again, we need those two diagonals to be congruent. All right, so this is where, again, writing down the points is helpful. What is point B? Point B is 3, 2. What is point D? Negative 2, negative 3. Okay, let's now check with doing distance formula. So it's the big square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to subtract the x's. This is going to equal the square root of x2 is negative 2, subtract 3, negative 2, subtract 3, and then square it. Add to it negative 3, subtract 2, square it. y2 minus y1. Okay, let's keep going. We're going to have the square root of negative 2 minus 3 is negative 5. Negative 5 squared is 25. Negative 3 minus 2 is negative 5 again. Squared is positive 25. So this diagonal BD is the square root of 50. Okay, the BD diagonal, here I'll even label it. We're finding the diagonals now. That's the square root of 50. Now we're hoping AC's diagonal is also square root of 50. If it's not, then we do not have a rectangle. Okay, so let's do it with AC. So AC's points, A is negative 3, negative 1, and C is 4, 0. Again, this has to come out to the square root of 50. Let's see if it does. Distance equals. We're going to do x2, which is 4, subtract x1, which is negative 3, square it, and then add to it y2 minus y1, 0 minus negative 1, squared. So the distance is going to equal the big square root. Minus minus turns to plus. 4 plus 3 is 7. 7 squared is 49. Minus minus turns to plus here. 1 squared is 1. So 49 plus 1 is square root of 50. So are the two diagonals congruent? They are. So because you have 4 right angles and diagonals, congruent, since you have diagonals are congruent and 4 right angles, you know that you have a rectangle. Okay? Now, real quickly to finish this off, how do I know that a rhombus is a rhombus? I know that we didn't do that today, and probably we'll do that in our next lesson, but how would I know that a rhombus is a rhombus? Well, I have, number 1, 4 congruent sides. Okay, and how would I check that I had 4 congruent sides? You would do distance formula. You'd have to do it for all 4 sides, though. Okay, that's going to take a little bit of work, but you can do it. 4 congruent sides. You also have that the diagonals are perpendicular. And this is where today's lesson would come in. Okay, how would I know that two diagonals are perpendicular? The slopes of the diagonals are opposite reciprocals. Okay, that's important. So if the slopes of the diagonals are opposite reciprocals, then you know the diagonals are perpendicular. Now I know it's also the diagonals bisect the opposite angles, but we're not going to be able to show that with these coordinate proofs at this point. So again, if I had a rhombus, if I was trying to prove some of this rhombus, I'm looking for 4 congruent sides and the diagonals to be perpendicular. Now, if you had a square, you would need 4 right angles and 4 congruent sides. So again, how do you find right angles? If the sides are opposite reciprocal slopes, okay, that's how you know you have right angles. The sides would be perpendicular and they would have opposite reciprocal slopes. And 4 congruent sides, you got to do that with distance formula. All right, so now you are off to a great start in this chapter. This is really all there is to this chapter. We have more work to do. Next week will be a busy week for us again, trying to figure out how to put this into play. We'll probably have another couple of videos to get us through, and hopefully some work together to help you review this and understand it. But that's the chapter right now already. But again, lots more work to go. All right, you guys have a great day. Make sure you do the homework today. Submit on School Loop tonight, and you will be set for getting your points through Google Classroom. All right, everybody have a good weekend, and I'll see you again on Tuesday.